Okay, so today's topic we'll be discussing about vector algebra of mathematics. Okay, so in that first topic about it is you need to know what is a vector. So before going for what is a vector, you need to know what actually comes before coming that of a vector quantity. So vector and scalar comes under a quantity called as a physical quantity. Like any example, if I talk about is something as example, if I can measure something, for example, length of this tester. For this, I can measure this, correct? No? So that means whatever is a measurable quantity is a physical quantity. Like any particular thing, if I cannot measure, then such a thing is not a physical quantity. Okay. So for example, I can tell is your feelings, emotions. We cannot measure it. So such type of a thing which we cannot measure cannot be called as a physical quantity. So first of all, we should know that whenever it comes to the definition of vectors or scalars or any particular things, a physical quantity word should be given no matter what. So which means a vector is a physical quantity which has both magnitude and direction. Okay, vector is a physical quantity which has both magnitude as well as direction. Okay, magnitude as well as direction. Such a type of physical quantity which has a value as well as the direction in which it passes through is called as a vector quantity. Okay, another thing, a scalar. A scalar is a physical quantity which only has a magnitude but no direction. Okay, so we can just tell that distance, as I told you, distance is measured, okay, something like 11 centimeters of this pen. This distance, only distance, no matter what direction you take, will remain the same. So which means it is independent of the direction. So such type of physical quantity which has only direction or independent of direction, only magnitude, no direction, only magnitude, okay, magnitude only. Such type of physical quantities are called as scalar quantities. So this is the basic idea for all, and few examples you can think about for vectors is displacement, velocity and force. Displacement has its direction as well, because you know displacement can be negative. Displacement can be negative means it has direction as well as magnitude. Value also will be there. Also velocity and force also falls under vector quantity itself, which has both magnitude and direction. Scalar quantities are distance. You can see the scalar quantity of displacement is nothing but distance. Yes. So that displacement has direction, whereas distance does not have a direction. If I tell from my house to that road is a certain value, distance, it does not have any direction. It's the same the other way direction as well. So which means distance is a scalar quantity of displacement and speed is the scalar quantity of velocity. So speed is nothing but a velocity without direction, or velocity is nothing but speed with the direction. So same as that. So speed is nothing but a scalar quantity, whereas velocity is the vector quantity. Same goes, another example for scalar is work, which has only magnitude, which I'm doing a work. I can tell I'm doing a work, I'm doing a certain amount of work, for example 10 joule of work or something. But I cannot tell in which direction the work is done. So that is what we are talking about when it comes to scalars and vectors. I hope it is clear as enough. Okay, any doubts? Please let me know. So next in this, you need to understand how do we represent a vector. So for representation of a vector, I will take a straight line. Okay, I will take a straight line, a random line, and I call that line as L. And L is nothing but a directed line. Okay, it's a straight line. An imaginary line also you can think of, an imaginary line which is denoted as L, and it is called as directed line. So after that, I will mark 2 points on that line itself, that is A and B. That 2 point marked will become line segment, and that is nothing but the initial point and the terminating point of a vector. Okay, the line joining A and E, and if I give a direction to that forms a vector, that is AB vector, or let me name that vector as a vector. Okay, see, whatever is the arrow mark which are marked here, that will determine the direction of a vector. Okay, not the arrow mark marked on the denotion letter. Okay, so for here you can see that AB has one direction, the arrow mark marked. This has nothing to do with the direction of the vector. Only the arrow mark marked on that line has something to do with the direction of the vector. Okay, this is just to indicate or denote how the vector is. So it can also be denoted as AB vector or A vector. This arrow mark above the letter is called as a vector, which means when I am reading this as AB, you will not read it as AB arrow. You will read it as AB vector or A vector. That is how you will read that. Okay, so whenever you see this term, you will read it as A vector. Suppose if it was something else other than that also, something like B, this is read as B vector. If there is an arrow mark on top of it, we will read it as a vector. So in this AB vector or A vector, A is the initial point, is the starting point of that vector, and B is the ending point or the terminating point of that vector. Okay. So after this comes the length of AB, whatever is the length. For example, let me assume this is somewhere around like 8 centimeters. Okay. So this 8 centimeter is nothing but the magnitude of the vector. So the length of this AB point or a distance between the AB point is nothing but the magnitude of that vector. So it is denoted as the modulus of AB vector or modulus of A vector. You read it as magnitude of A. You don't read it as modulus. Okay. The two lines indicates that it is the magnitude of that given vector. Okay. So the magnitude of vector, this is nothing but the magnitude of A or magnitude of AB. It is one and the same. So we'll be majorly using this denotion. We'll convert that vector into a small, in slower case later, and then go on denoting the vector quantity.